I've been dreaming on in my head like I've seen it. A life worth living is a life with meaning. I'll do what I love till my heart stops beating. I'm feeding this demon. Got a taste, can't erase bitterness in my face. Work a job every day till your dreams fade away. Like a card, never change, play the game that we say. I need a break. Time staying strong, need to move on to be what I want. I'll keep dreaming on. Time staying strong, need to move on to be what I want. I'll keep dreaming on. Face on when I chase like that, yeah, I play so strong with a knife in the back. I'ma swing home run like a baseball bat. Gonna see me rise, you can hate on that. I don't play both sides, doing me no cap. I'ma ride or die for my dreams on tap. I'ma fly real high, you ain't see me slack. No, it's not how you fall, it's how you get right back up. That's how you get tough, calluses on my hands so rough. Yeah, I call your bluff, I'm not the one. Mess with me and come out with none, cause I'm so done. You had your fun, and now you're gonna face down the barrel of the gun. Cause I got a full clip, put your name on it, but I'ma let you slide cause you ain't worth it. Time staying strong, need to move on to be what I want. I'll keep dreaming on. Time staying strong, need to move on to be what I want. I'll keep dreaming on.
Hello and welcome back to the channel Airbus What's It Doing Now. Today I'm going to take a look at the Airbus Safety article which was released recently relating to landing with nose wheels at 90 degrees, and it's a continuation from the landing gear briefing I gave recently. So I'm going to take a look at the events, and I think from memory there are 5 events here. One with a nose landing gear component structural failure, all to do with the lugs at the top of the landing gear. Then I'm going to take a look at the next event, which was BSCU failures and the BSCU upgrade. Another one is a combination of independent failures, water ingress in the nose landing gear steering sensors, and then lastly, quite a shocking one actually, the last case, case 5, which involved a 180 degree turn with the nose landing gear inoperative before takeoff, something I believe is non-dispatchable now after this event. So the way I'm going to do this is a bit of a podcast, in so much as I'm just going to read out almost word for word with a few other references in there what is actually written in this operations for the nose landing gear safety article, and then what I'll do is I'll screen grab some shots and put that as part of the briefing if you are watching this through. But if not, and you're in the car, of course you can just put this with the Bluetooth on your speakers and just listen to this as a podcast, and perhaps watch the video later on with the photos if that's what you prefer to do. So let me just begin with it. If anybody wants to have access to this, you can do, of course. It's in the Airbus Safety Magazine. It's Airbus safetyfirst.airbus.com, and this one is / landing with nose wheels at 90 degrees. You'll find it on a Google search, no problem at all. It's available to download as a PDF. So let's get straight into it then. So landing with nose wheels at 90 degrees. In the past few years, several events occurred involving landing gear or landing with nose landing gear wheels turned to 90 degrees from the aircraft centerline. The investigations identified root causes which were different in each case, and I think that's the big takeaway here. Mitigating actions were developed and deployed accordingly, which also involved upgrading some BSCU standards, changes to the MEL, and 1 or 2 engineering items as well in terms of configuration for the gear. This article describes the outcomes of investigations into several events of aircraft landing with nose landing gear wheels at 90 degrees and shows why they are not related. It also recalls the corrective actions and existing operational recommendations to prevent any occurrence. So there's some good take-homes there on as conclusions to these events. So let's take a look then at case 1, nose landing gear component structural failure. Now, the event description: in 2005, during the takeoff of an A320 family aircraft, a few seconds after landing gear retraction was commanded, the ECAM landing gear shock absorber fault ECAM alert was triggered, followed by nose-wheel steering fault ECAM alert. Now, we looked at this in the landing gear briefing. When you get these two faults together, would indicate that there is a nose wheel problem, and there's an FCOM procedure for it. As a result, the flight crew was not able to retract the nose landing gear. They suspected an issue with the gear, and so they performed a flyby, allowing ATC to observe the situation of the nose landing gear. ATC confirmed to the crew that the nose wheels of the aircraft were in fact turned at 90 degrees. The flight crew decided to divert to an airport with a longer runway. Sensible choice. The aircraft remained airborne to use fuel for landing, obviously to reduce the landing weight. The aircraft touched down on the runway, and the flight crew delayed the nose wheel touchdown by not using ground spoilers, auto brake, or applying reverse thrust. The nose wheel tires burst shortly after touchdown, and the wheels on the runway generated lots of sparks. The aircraft remained on the runway centerline. After the aircraft stopped, the flight crew deemed that it was not necessary to perform an emergency evacuations, and all passengers disembarked the aircraft using the stairs. So going on to the event analysis, there are two lugs on the upper support of the nose landing gear shock absorber that prevent it from rotating freely. This is shown in figure 1. I'll put it up on the screen. The investigation showed that both lugs had sheared off. This caused the nose landing gear to lose its centered position. This condition was immediately detected by the landing gear control interface unit, the LGCIU, which triggered the landing gear shock absorber fault ECAM alert. The braking steering control unit, BSCU, also detected the rotation and deactivated the nose wheel steering system. This then, of course, triggered the nose wheel steering fault ECAM alert. The absence of nose wheel steering, combined with the broken anti-rotation lugs on the gear itself and the aerodynamic loads, enabled the nose landing gear to rotate through 90 degrees from the centerline. It was discovered that the BSCU standard fitted to the aircraft at the time performed a greater number of steering movements during the pre-land checks compared to previous BSCU standards. This caused more fatigue to the two lugs on the upper support of the shock absorber. The internal pressure of the shock absorber was also found to be too high due to incorrect service during maintenance. This all then resulted in additional friction being applied to the nose landing gear center mechanism device, which is connected to the upper support, and eventually caused the two lugs to shear. So some maintenance issues there, together with an older standard BSCU, eventually caused these components to fail. So prevention, new BSCU standard. The BSCU standard L4.9B was developed with a reduced number of steering movements during pre-land tests. The retrofit of this new standard is complete. The BSCU standard responsible for the lug failure is no longer in service. So that's great to hear. The temporary solution published OEB 175176 is no longer applicable for any 320 aircraft. And now that the BSCU retrofit campaign is complete. Now, I don't remember seeing OEB 175176, but some of you operators out of Europe maybe may have seen it related to this older standard BSCU, perhaps. I don't know. But I personally haven't seen it. If you have, please leave it in the comments. Key point, in the case of landing gear shock absorber fault and the nose wheel steering fault ECAM alerts, no reset is authorized in flight of any 320 family aircraft. When you look through the FCOM for landing gear, if landing gear shock absorber fault is associated with nose wheel steering fault, it clearly states in there that they might be at 90 degrees and to hold the nose gear off as long as possible. Correct shock absorber servicing. Well, this is all to do with maintenance, but before this event it was possible to perform servicing of the shock absorber with a weight on wheels, which was difficult to service the correct pressure. This led to a tendency to over-pressurize the shock absorber and cause increased fatigue on its upper landing gear support. Nose landing gear shock absorber servicing procedures were improved following the event to allow for easier servicing of the weight off wheels using jacks on the nose landing gear. If the shock absorber can only be serviced with weight on wheels, then servicing tasks must be done again and with weight off wheels in the next 7 days. So that largely cancelled that out then. Best practice, the AMN procedures must be followed when servicing the nose landing gear shock absorber. In particular, the jacks for the nose landing gear should be used to ensure servicing of the optimum pressure for those shock absorbers. This will minimise the risk of pressure, which can cause structural fatigue to the nose landing gear components. Now, these were also improved. There's a photograph here of the initial design and the more robust looking improved design. So following another event that led to the landing gear rotated at 90 degrees, which was caused by installation errors during maintenance, a new foolproof design of the nose landing gear shock absorber was introduced. This design prevents any lug rupture on the upper support of the shock absorber, and it's installed on all 320 aircraft in production since 2004. And there's a reference there, SPA 320 321277 mod 34160 is available for retrofit. Cool. Okay, so lots of upgrades there really in the lugs and the BSCU standard, and upper support for the nose landing gear shock absorber, making it very difficult for those lugs to rupture. Yeah, you know, we all learn from these things, don't we? I mean, of course, how many Airbus 320s are there in service at the moment? It's a short haul aircraft doing multiple landings, multiple gear extension and retraction. So it's through these events that you see the fatigue that these systems go through, and you know, they develop this all the time to improve its reliability. So case study 2, BSCU failure. In 2007, after takeoff from an A320 aircraft, the auto brake max on light remained, which of course it should go off after gear retraction, and the brake system 2 fault ECAM was also triggered. During the cruise, the flight crew pressed the auto brake max push button, presumably to turn it off. They also set the anti-skid nose wheel steering switch to off and then back to on, which was not requested by the ECAM QRH OEP procedure. This had no effect on the auto brake max light. We have to be really careful about doing resets that aren't certified or aren't listed in the QRH. It's not a procedure. Because as we know with the Airbus, these systems have multiple connections and we can actually make the situation worse. So on the approach, the auto brake max lights remained on after landing gear was extended, and then they got the landing gear shock absorber fault, ECAM. The flight crew set the anti-skid nose wheel steering to off and the auto brake max on light went off, but the ECAM remained. The flight crew eventually landed with the aircraft turned through 90 degrees along the centre line. So again, brake system fault here, landing shock absorber fault on here, and the auto brake light staying on. Now, the event analysis, it was found that the nose wheels were able to rotate up to 90 degrees because of a hardware failure on this particular BSCU. The BSCU remained active, but it could not be controlled, and its outputs became frozen. So for some reason, it was locked in that position. This then caused the brake system 2 fault ECAM alert and the malfunction of the auto brake light as the system's connected. Prevention. An update design was introduced to improve the robustness of the BSCU to allow a switch over to the passive, that's the remaining system. when the outputs of the active BSCU system become frozen, i.e. switch from 1 to 2. That normally happens with the landing gear. The retrofit update to the BSCU standard was mandatory and is now complete, and there are no reported events of similar root cause events after the BSCU standard was replaced. Case 3, combination of independent failures. So in 2011, during the cruise of an A320 family aircraft, nav ILS 1 fault ECAM triggered, followed by Nosewheel steering fault ECAM alert. The flight crew observed the captain's PFD went blank for a few seconds. This is a bad day. There's quite a few things going on here, and this all comes, I think, from reading on to some sort of transient electrical problem. On the approach, the landing gear shock absorber fault ECAM alert was triggered after extension of the landing gear. The flight crew suspected a Nosewheel steering issue, so they performed a flyby for the ATC to check the position of the nose landing gear. Good idea. The ATC confirmed that the wheels were turned through 90 degrees from the aircraft centerline. The flight crew landed the aircraft by delaying the nose landing gear touchdowns recommended in the FCOM 320 FCOM procedure, which was applied when both the shock absorber fault and the Nosewheel steering fault ECAM alerts are triggered. I made reference to this in the FCOM. The aircraft safely came to a stop and the passengers disembarked using the stairs. There were no injuries, and one Nosewheel tyre was damaged during this event. That's a good show, just one tyre. Event analysis. So when the landing gear was extended, no steering control was available because an electrical transient in the power supply to BSCU1 caused a loss of the steering function. So that will probably explain the flickering of the PFD. The Nosewheel steering fault ECAM also triggered. The electrical power transient was due to an arcing at a connector on IDG1. Power transients affecting BSCU1 were already observed on several previous flights. So obviously this is an ongoing problem, or was an ongoing problem on that aircraft. It was also found that a maintenance task on the nose landing gear was not correctly carried out, and this resulted in the hydraulic selector valve jammed in the open position. Interesting. This would usually be detected by pre-land test. However, the flight crew were not able to perform the test due to the fault in the landing gear lever position. This was also found present on previous flights, so quite a bit going on here. With the selector valve jammed open, there was hydraulic pressure on the nose wheel when the landing gear was extended. The nose wheel began to turn due to the loss of the steering function. Then they got the landing gear shock absorber fault because the landing gear wasn't centered. The BSCU system 1 switched to system 2, but the nose wheel system remained inactive as it detected that the nose wheels were not centered. The nose wheel continued then to go around to 90 degrees. Very interesting. Prevention. In the case of a fault of the landing gear lever position, the brake system 1-2 fault ECAM is now triggered. So in the case of a fault of the landing gear lever position, BSCU1 system is now triggered, 1 or 2. This improvement is available from standard L410. It's installed in all 320 aircraft produced since 16, and it's available for refit. The BSCU standard, since the introduction of L49B, the BSCU now centers the nose landing gear in the case of no pre-land tests that are performed. This retrofit is now is the new standard, and it is complete. So if it's not able because of BSCU problem, if no pre-land tests are able to be completed, then it will center the nose wheel. Display unit failure, the QRH procedure. In the event that the power transient that affected the BSCU was not sufficient to switch to the BSCU2 sooner, would have prevented the nose landing gear from turning through 90 degrees. So if it was able during that transit of the power, or the transient power, to switch over to BSCU2, then the event would have been, it wouldn't have been an event. If the PFD flickers with no ELEC Gen 1 fault, the flight crew should perform the display unit failure QRH abnormal procedure. And if you read through that DU procedure, it calls for, if the PFD on the captain's side is flickering, to turn off the generator 1, and conversely, if it's on the FO side, it's generator 2 should be selected off. The application of this procedure forces the BSCU to switch from 1 to 2 or from 2 to 1, whichever's in control at the time. That I didn't know, so that's really useful. So flicking off the generator will swap control of the BSCUs. So if you had that transient power situation and it doesn't go over to BSCU2, as is the case in this crew, whether you'd know about it or not, I don't know. But if you got a flicker of your PFD, which would indicate a transient power problem, then carrying out that procedure is going to sort out your problem. Happy days. All these things that are built in that you just don't know about. So the procedures are written, and of course they're written for a reason. But you don't always know exactly why, or there might be some things that are hidden behind. So case 4, water ingress in the nose landing gear steering sensors, the event description in January 21, so very recently, during the approach of an A320 family aircraft, the landing gear shock absorber fault and nose wheel steering fault. We're getting a picture here of what this is what's going to happen here. Alerts were triggered after extension of the landing gear. The flight crew set the anti-skid nose wheel steering switch to off and back to on again, even though it was not requested by the ECAM QRH OEB. It wasn't requested at all. The flight crew landed the aircraft and delayed the nose landing gear touchdown as long as possible, as recommended by the FCOM procedure, which is applicable when you see those 2 ECAM alerts. The nose landing gear touchdown, both the nose landing gear tires burst and the aircraft stopped on the runway. There were no injuries. The landing gear were turned through 90 degrees from the aircraft center line, and the skid marks of more than 1,200 meters long were found on the runway. Event analysis. During the inspection of the nose landing gear after the event, water was found in the 2 rotary variable differential transformers, the RVDTs. That's a mouthful. These 2 sensors provide angle of nose wheel steering position to the BSCUs. There you go, it's got angle sensors. Of course it would have. 3 days before the event, the aircraft was cleaned during a maintenance C-check. Water ingress into the RVDTs most probably happened at this time. Now that's really interesting, isn't it? And aircraft do get a wash from time to time. A ferry flight was performed after the C-check and cleaned. Analysis of the flight data recorder showed that 1 RVDT was blocked during this flight. It is likely that this was due to the water in the RVDT freezing at altitude, but was probably unblocked as the ice broke up upon landing. A steering offset resulted from this flight and remained for the next 7 flights. Steering offset, very interesting, because we know that there's a limit, isn't there, as to what offset we can accept. It around 3 degrees or something. The steering. Okay, so I took a look at this, and it's in the FCOM supplementary procedures landing gear, and it's under the title Operation with Nose Wheel Steering Offset. Now, the table you can look at for yourself. I'm not going to put it up here, but your table starts with nose wheel steering offset. You don't actually really know what that means. It's more of a maintenance thing, but what you will see is what's required in order to taxi in a straight line. That's a necessary rudder trim input, equal to or less than 3 degrees, between 3 and 8.8. And if you require more than 8.8 units of trim, it's maintenance action. Do not attempt takeoff. Request for troubleshooting. So, yeah, that's worth a look at there. The rudder trim reset must be performed for takeoff if it is within limits. When the rudder trim adjustment is above the maintenance tolerance, plus or minus 5 degrees nose wheel offset corresponding to plus 3 degrees rudder trim necessary to run go straight, the flight crew must systematically and accurately report the rudder trim value in the logbook. That was almost 2 degrees during the taxi out of the flight when the event occurred. The flight crew kept the aircraft from veering off course and continued with the takeoff. So that is well worth reviewing. The landing gear shock absorber, and I'm going to look at that before I finish this, and I'll put a little note at the bottom. The landing gear shock absorber fault and wheel nose wheel steering fault ECAM were triggered. Funny that. When the landing gear extended, the nose wheel was already at an angle that was too excessive to be corrected by normal mechanical self-alignment of the wheels. So it's not saying it was at 90 degrees at this point, but when the flight crew inappropriately cycled the anti-skid nose wheel steering switch, they reactivated the BSCU and hydraulic pressure was supplied to the steering actuator. During the pre-land test, the BSCU could not center the nose wheels because of the faulty sensor, and the angle of the nose wheel steering position was already too excessive. This resulted in the nose wheel rotating further toward 90 degrees before landing. So by turning that anti-skid nose wheel steering off, they obviously made the situation worse, took the power away from it, and it just whipped through 90 degrees. Prevention: compliance with the AMM-MP tasks after aircraft washing. The AMM-MP task for nose landing gear washing must be followed, and there's a big paragraph there about external cleaning, which refers to various AMM. These tasks clearly warn against the use of high pressure hoses. And provide details on protections to be used. So obviously somebody got a Karcher a little bit too close to some of these sensors, and of course had some water ingress. Operations with nose wheel steering offset. The operation with nose wheel steering offset A320 FCOM supplementary procedure states that the flight crew should not attempt to take off with an offset exceeding 1.5 degrees. The nose wheel steering offset is determined based on rudder trim input necessary to cancel the tendency of the aircraft to veer out on taxi. We need to review that. No system resets were not authorised. A bit of double negative there. The flight crew must only perform authorised reset procedures in flight. That's an important take home. They are described in the system reset table in the A320 QRH. If the flight crew perform a reset that is not listed in this table, it could lead to unintended serious incidents. I think they've made their point. Key point, they're going to make it again. The flight crew must only attempt authorised resets as per the system table in the QRH. Unauthorised resets can have dramatic consequences. More information about authorised system resets are available. System reset used with caution, safety first article. Okay, if you want to have a look at that. Now, the last one we're going to have a look at is really interesting. Case number 5, 180 degree turn with the nose landing gear inoperative before takeoff. Now, it says later on in this article that it's not dispatchable after this event. But in March 21, so that's very recent, isn't it? An A320 family aircraft was dispatched with nose wheel steering inoperative MEL 325101 nose wheel steering control system. This was due to a failure detected by the BSCU. They had a nose wheel steering fault. ECAM was triggered during engine start, and as expected for the dispatch under the MEL. So they're going to get that because it was an operational procedure that you expect to see with the MEL. The MEL operational procedure states that the flight crew must avoid sharp turns when the nose wheel steering is inoperative. During differential braking and asymmetric thrust were used to steer the aircraft during the taxi out. Sounds normal. The flight crew then performed a 180 degree turn to align the aircraft on the runway, contrary to the conditions set out by the MEL. So yeah, no sharp turns, 180 degrees, gosh. After liftoff, the landing gear shock absorber fault ECAM was triggered and the landing gear was jammed in the down position. The flight crew performed an in-flight turn back and landed the aircraft. The nose landing gear had rotated 90 degrees and both nose landing gear tyres burst on landing. Event analysis: the nose landing gear were free to caster, and it shows you in figure 5 what that means because of the inoperative nose wheel steering. Now, free to caster is a nice diagram here. The nose landing gear will return to 0 degrees after up to 15 degrees of nose wheel steering due to the self-centering effect offered by the rake angle of the leg. Now the rake angle is if you imagine a 90 degrees from the aircraft to the wheelbase here, that would be a rake angle of 0. Not 90 degrees, 0, okay, because it's perpendicular to the aircraft. The rake angle basically is the angle that extends the nose forward or rearwards, but in our case forwards. That's the rake angle from the vertical. And you'd notice actually, if you look at an aircraft taxiing as they turn, you see that the nose gear is slightly leaned forwards. That's the rake angle. If you're into motorcycling, then the rake angle you'll see is that from the stock head, the forks go down to the wheel. You know, the big chopper motorcycles that you see in Orange County motorcycles, and the big Harleys with the handlebars up here and the long forks that stretch forward. They have huge rake angle. They don't turn. They don't turn at all, actually, but ideal for American roads. And the shorter that rake angle, the shorter the wheelbase, and the more manoeuvrable your motorcycle. So if you're into MotoGP and they talk about rake angles, they're changing those things all the time to make the aircraft, to make the motorcycle turn more. Anyway, totally unrelated to what we're talking about. So in free to caster mode, the nose landing gear wheels will turn to 0 degrees up to 15 degrees of steering angle due to the self-centering effect offered by the rake angle of the leg. Between 15 and 25, the wheels will return to 0, but with more difficulty. If the nose wheel steering angle exceeds 25 degrees, then with no hydraulic pressure there, the wheel will then just go around to 90 degrees. Analysis of the recorded data showed the evolution of the nose wheel steering angle during the taxi out, which resulted in a U-turn. So they must have gone to a runway, had a turning circle at the end, and they needed the full runway available. The nose landing gear wheels remained below 15 degrees during the first left turn and naturally returned to the centered position as they're doing the backtrack. During the right turn, when they come through 180 degrees, the angle of the wheels turned by more than 25 degrees, which means they will continue now to rotate towards 90 degrees position at the end of the sharp 180 degree turn. Now here's the interesting thing, the wheels remained in the 90 degree position during the takeoff roll and upon landing. So, and those wheels at 90 degrees, and you can take off like that. I mean, that must have created a heck of a noise. The landing gear shock absorber fault ECAM alert was triggered at takeoff because the nose wheels were not centered at 0. This prevented the flight crew from retracting the gear. Should have prevented them from taking off in the first place, but there we have it. Prevention. There were very few cases of dispatch with an operative nose wheel steering on 320 aircraft reported to Airbus over the last 15 years. Dispatching an aircraft with an operative nose wheel steering requires operational precautions that are explained in the associated operational procedure. Even if the safety analysis showed that an acceptable level of safety is granted when dispatching an aircraft without operative nose wheel steering system, the operational burden is significant. For that reason, and to avoid such an event occurring again, the nose wheel steering system 325101 will be removed from the MMEL. It would no longer be possible to dispatch an aircraft with an inoperative nose wheel steering system. The updated master MMEL revision will be available in February 22. So that's like as we speak. An FOT will be published to further explain the rationale for removing this MMEL item and to provide appropriate mitigation means in the case of inoperative nose wheel steering. It is not possible to dispatch other Airbus types with an operative main nose landing gear due to design differences. The only exception is 300-310 family aircraft based on in-service experience and the design of the 300-310 nose landing gear. The wheels are not likely to turn at 90 degrees. Oh, there you go. Perhaps because of their rake or something, or by pure design. Operational recommendations. The A320 FCOM mentions the possibility of having nose landing gear wheels at 90 degrees when both the nose wheel steering fault and landing gear shock absorber fault ECAM alerts are triggered, and recommends the delaying of the nose wheel at touchdown and landing. That's what we spoke about earlier on. So just in summary here, the events in recent years where 320 family aircraft landed with their nose landing gears turned through 90 degrees have different root causes and are not related. There were no serious injuries or fatalities, and the damage caused of the nose gears on the aircraft were repairable. Quite extraordinary, really. The actions were taken to prevent a recurrence of each event. Updated brake and steering control units, BSCU standards, were developed and retrofitted. Improved design of the upper support of the nose landing gear shock absorber was deployed on the 320 family fleet. And following the maintenance and operational procedures remains the strongest safety net to prevent such an occurrence, and compliance with the AMM tasks is essential for shock absorber servicing to avoid overpressure condition for the aircraft washing, to warn against the use of high pressure hoses. It is also important for flight crews to remember that they must only perform the authorized reset procedure in flight, which is described in the system reset table of the A320 QRH. If the flight crew performs a reset that is not listed in the table, this could lead to unintended serious incidents. The action taken is to prevent the dispatch of an aircraft with a nose wheel steering system operative in order to avoid the risk of having a nose wheel at 90 degrees. So very interesting stuff. Like I said, that's available for you to download as a PDF and read at your leisure. But if you want to have a look further, I hope you've enjoyed the briefing. Thanks very much for watching. Hope you found it useful, and keep the plate spinning. I'll talk to you again very soon.